So let's look at the second part of this problem, which is part B. We have to determine the final temperature of the steam. But the first formula which we derive is the formula which we have to use for this problem. And let me just write the formula for you to have a rethink of this formula. We have heat minus work, which is other form of work, equal to what? Equal to the formula for change of enthalpy, which can be what? H2 minus H1. And this formula can be written in this form. Heat minus work for other substance can be written as what? Because the system has a mass, and because it has a mass, it has enthalpy. I may write it as such: mass into what? H2 minus H1. So this is mass. This is what? Enthalpy at point 2, and this is what? Enthalpy at point 1. And because of that, but why am I thinking about enthalpy at point 2 and enthalpy at point 1? Because I will easily get T2 from H2. I can use the property table. And at pressure 2. So this, I'm going to use the property table. So the first thing, you have to think smart. I can never get T2. So to get T2, I must think smart. By what? By looking at process or technique that can give me T2. So basically that is what we do in thermodynamics. We try to use the formula which can give us the variable that we are trying to calculate. And because you have to do that, you're going to get the answer quickly. Now, see what I'm going to do next. I can now try to get my H1. Because when I get H1, I can get H2. And when I get H2, I can get T2. That's what I'm trying to explain. That's what I'm trying to explain here. So, see what is going to happen now. For me to get H1, I want to start by looking at the equation. Determine the final temperature at the system. Can I get H1 without looking at the work done for the system? The answer is, it's important to get the work done for the system because the work done is part of the formula. Remember, we have the work done for the system, or let me just say, which is equal to what? other work. Let me write in a way you can see easily. Other work, and that other work from this problem, the other work you see from this problem is electrical work. So it's electrical work, and electrical work is gotten by what? By using the current times the voltage with respect to what? Change of T. So this is current, this is voltage, this is change of time. And if you do that, you're gonna see that the other work, which is in this case is electric work, have 120 volt times 0.2 ampere, and the time is 300 seconds. And to get to standard unit, I multiply by 1 kilojoules per second over 1000 volt ampere. I'm going to get what? I'm going to get 7.2 kilojoules. That is the work done for the system. Then I know that from the problem I have the pressure. I have the pressure, the constant pressure for this saturated fluid. So I've already gotten the work done. I've gotten the work done for the system, which is electric work done. Now I need to get the enthalpy for this process, for this work done. So I come now, and that is actually state 1. So this is state 1. For that state 1, I have the pressure, which is equal to what? 300 kilopascal, and I have the fluid is actually as saturation vapor, and I'm going to get what? H1, and that H1 must be gotten at what? For that vapor, the enthalpy for that vapor at 300 kilopascal. And I ask myself, which property table am I gonna use? Property table am I gonna use? I have the substance, I have the property. When I look at the substance and property, I know that the substance is steam, because water increases in pressure, and that water becomes steam, and therefore I'm gonna have steam, which is water, and I can say the table which I'm gonna use here is table A5, which is table A5, because I have saturated vapor, which is steam water, and for that pressure of 300 kilopascal. Now I go to table A5. I'm looking for what? I'm looking for H vapor, H1 vapor. So go to table A5. This is A5, and I have saturated water, and at the pressure of what? At the pressure of 300 kilopascal. This is the pressure. The unit is in kilopascal, and then I have to make a good choice of table A5. A pressure of 300 kilopascal. I'm looking for what? I'm looking for H vapor. Looking for H vapor. So I'm looking for H vapor to Hg at 300 kilopascal. So I'm coming. And this is my H is equal to what? Is equal to 2724.9 kilojoules per kilogram. Kilojoules per kilogram. So I come here now. This becomes what? Become 2724.9 kilojoules per kilogram. And that is the property table value which I have. So I have H1. Now I move now to solve for H2, because at H2 we will get T2, and it is still the same process that is undergoing change of energy. So I'll have what I'll have. I'm going to have the same formula: energy into the system minus energy out of the system is equal to what? Change of energy for the system. And in this case, I've solved for the work done. The work done into the system minus the heat that went out of the system minus the boundary work equal to what? Change of internal energy. And I already have this as what? 7.2 kilojoules, and this is 3.7 kilojoules. And I have what also? I have this, and this. Gives me a value of what? Change of enthalpy, which is what? M into what? H2 minus H1. Remember this is change of enthalpy. So in that case, I have this, which is this, as what? M into what? H2 minus H1. And if you look at the question, what is the mass? The mass is 0.025 kilogram. I have H2 minus what? I saw for H1, which is 2724.9. It therefore means that my H2, which is enthalpy at point 2, can be what? 2864.9 kilojoules per kilogram. Now I go now to my property table. I say state 2. I have P2, which is what? Which is constant pressure. So P1 was equal to what? P2 was equal to what? 300 kilopascal. So I have 300 kilopascal, and H2, which I solve for, is equal to this 2864.9 kilojoules per kilogram. So these two of them, I will be able to get, what? T2. And that T2 is 200 degrees Celsius from what? From table A6, which is the correct table for that. And so you can see that we had to solve for T2 by just using the right property table. And how do we use the right property table? We need to get H2. How do we get H2? We need to use the formula for what? The formula for what? The formula for work done for the system. So this formula is very important. And what do we actually use? We actually use the formula as such. We actually use but this formula. That's the main formula which we use if you look technically. So therefore, you may be able to know that the main formula which I use, I'm going to write this in a writer. I use this formula. I'll write it here. I use the work done, which is the electrical work done into the system. It was positive minus the heat that went out of the system. It's equal to what? Which is equal to what? This is equal to what? Change of enthalpy, which can be equal to what? H2 minus H1. And then we see that we can write it as what? Because we are looking for H1 and H2. So this formula is applicable. Based on the data, I need to get T2. I need to get T2 so I could be able to use enthalpy, because I know the mass was given. So this work done for the system that you see here, heat came out of the system. We have negative heat because heat got out of the system. Work got into the system. We have positive work into the system. So technically, I'm saying that for every system, you have to write the equation of energy balance. For this system, I can see that work into the system was positive because electricity got into the system. But there was a loss of energy due to heat. So this heat was coming out of the system. I have negative energy for heat. It's equal to what? It's equal to the internal, the work done in terms of what? The energy, which is total energy for the system, which you may say change of energy for the system. And that change of energy for the system is equal to what? So that is the change of energy with respect to enthalpy, because the problem, the energy, this change of energy can be what? Kinetic energy change, potential energy change, and change of internal energy. But for constant pressure, this is 0, this is 0, but this is equal to what? The change of potential energy. So make no mistake, don't get confused. That's why you saw me using this main formula, and I use this formula to be translated into that form, and I solve for this H2. And yeah, so go through this again, and we're going to do some example in class, and you are going to understand when we solve the problem together in class on Monday. We're going to do another example based on what we've done. God bless you. Have a nice day. Bye-bye. Thank you.